Hi, let's try this again. I've been struggling with recording this lecture this morning, so hopefully this time it will work. Okay, so you've seen all the videos on linear algebra online, I hope, and they talk about the more abstract nature of what linear algebra is, that it's, it's a function from here to there, that it plays with the planes. What I want to do is I need to get to the nitty-gritty and kind of help you with the gross calculation-y stuff we need to do. So first off, let's just start with a matrix. A matrix is a rectangle of numbers. That's all it is. I have two of them over here on Maple that I made up, and my pointer's not working. There we go. Here's my A matrix. So A has 3 rows and 2 columns. So we would call this a 3 by 2 matrix. Notice that B is 2 rows and 4 columns. So this is 2 by 4. So first off, what can we do with the matrix? We can do scalar multiplication. Can't spell. Close. That is when you multiply. Oops, you probably can't see it because the camera's not looking at it. That is when you multiply a matrix by a single number. So I could say like -2 times b, which means I would take all the numbers in b and multiply them by 2. So I get -4, -6, +4, 6 again, -6 again, -2, that was a 4, so that's -8, -2, +2, God, I'm getting bad, and -2 times 4 is what? -8, there we go. So that's pretty straightforward. When you add two matrices, you add them component-wise, so they have to be the same size. So let's say I have matrix A, get so you can see it. Different matrix. Let's say, oh no, let's use the same one because I'm boring. 1, 2, 3, 4, 5, 6. And let's have matrix C equal -1, 1, -2, 2, 17, 6, because I'm weird. Okay, so if we do A plus B, A plus C, we do this component-wise. So we're gonna have 3 by 2 when we're done. 1 plus -1 is 0. You can see this. 2 plus 1 is 3, and so on. 17 plus 5 is 22, 12. If I wanted to say A minus C, that's the same thing as running a -1 through the C matrix. So I'd get 1 plus 1, 2 minus 1, 3 minus a -2, which is a +2, so that's 5. 4 minus 2 is 2. 5 minus 17 is -12. 6 minus 6 is 0. So that's how you do adding and subtracting, whatever. Now, multiplication is more of a pain in the butt. So let's say I've got matrix A, which is, we said this was 1, 2, 3, 4, 5, 6. And this matrix is 3 by 2. And matrix B we have is 2, 3, -2, 3, 1, 4, -1, -4, which is 2 by 4. To multiply two matrices, so you have A, which is, let's call it M by N. and B is N by P. These middle numbers must be the same. You can't see any of that. These middle terms must be the same. Let's try this. Rink. For this multiplication to be defined. And the result, I've already used C, let's call it D, will be M by P. So let's do one. So if I have, again, I'm too far up. There we go. So 1, 2, 3, 4, 5, 6. And we have 2, 3, negative 2. So the way I think about this is I'm taking this first column, and each column has to hit all the rows. So in my mind, I take 2 and 3 and kind of stick them up here. Can you see that? I can't see that. Hopefully you can see that. So what this means is this first column has to go down all the rows. So this first column, I have 2 times 1 plus 3 times 2. Then I'll have 2 times 3 plus 3 times 4. Then I'll have 2 times 5 plus 3 times 6. And then I'll do that again. Wow, I wish I hadn't picked such a big matrix. Okay, so I'm going to do the same thing with this negative 2, negative 3, negative 2, 3. So I will have negative 2 times 1 plus 3 times 2, negative 2 times 3 plus 3 times 4, negative 2 times 5 plus 3 times 6. And then I'm going to keep doing that with this one, and I'll have to add these together. I'm running out of space here. Oh, and I'm about to take you off the board. So 2 plus 6 is 8. 6 plus 12 is 18. 10 plus 18 is 28. And we finish that out. And simplify, and we will get 4, 6, 8, 9, 19, 29. These are the 2 rows, columns I haven't done yet, or didn't do on camera. 9, negative 19, and negative 29. Okay. Let me try a smaller one that's not quite so big and gross. Let's say we want negative 1, 3, 4, negative 2. And I'm going to multiply by 5, 7, negative 1, 1. So this one's 2 by 2, this one's 2 by 2. The result will be 2 by 2. So I have 5 times negative 1 plus negative 1 times 3. Next I'll have 5 times 4 plus, oh, not negative 1. It's been a long day. That should be 7. 5 times negative 1, 3 times 7. 5 times 4, negative 2 times 7. And then using the next row, I have negative 1 times negative 1 plus 3. So 1 plus 3 gives me 4. Negative 4 plus negative 2 gives me negative 6. Let me simplify that first column real quick. Negative 5 and 21, 16. 20 minus 14 is 6, and I already did that one. So that's matrix multiplication. The last thing I want to go over is putting a matrix in reduced row echelon form. So before I do that, I want to tell you about what we're allowed to do to a matrix when we're doing this. So we can switch rows. we can multiply the rows by non-zero numbers. And lastly, we can add two rows together. Now, if you think about it, what we are doing is, if you think about the rows as representing equations, and we're solving the equations, the matrix just keeps track of the coefficients, so we don't have to keep writing x, y, z, or x sub 1, x sub 2, y sub 1, whatever. So when we switch rows, we're just rewriting, putting one equation above the other. It doesn't really make a difference. If I multiply a row by a number, it doesn't change the fact that it's still a true equation. X equals 5 means 2x equals 10. No biggie. If you add two rows together, that's how you went about solving equations. You added one plus the other one, or subtracted one from the other one, or you would, say 5 times this one plus 2 times that one, just to get rid of variables. That's what we're going to be doing, but we're going to work on doing it more abstractly. We're just looking at the matrix. When you put a matrix in reduced row echelon form, your goal is to, each row, the first non-zero number on each row must be a 1. And this is called a pivot. Second, all the numbers above and below a pivot are 0. The pivots are in echelon form. Let me shift this over. I can't see. Camera's in the way. And what I mean by that is the first one is going to be the farthest left. On the next row that has a pivot, its pivot's going to be a little bit more to the right, then a little bit more to the right. So your ones are going to kind of go down like that. I mean, you may have a 1 here, but it may be nothing here, and then a 1 here, and a 1 here. But the ones have to go down diagonally. So I'm going to say pivots are arranged. What did I say? Going down. Can't spell. From upper left to lower right. And of course you're losing that. Okay, a second. And lastly, the rows that are all 0 get pushed to the bottom, if there are any. Not apostrophe. So let's try this with an example. Suppose we have the matrix 1, 2, -1, -3, 2, -3, 2, 13, -1. So when you do this, you want to do it very methodically. You're going to start with the first row, first column, then second, then third, and move your way across. So the first thing I want to do is I want to get a 1 in this position, which I already have, which is great. So now I'm going to use this 1 to get rid of the 2 and the -1 below it. So get the zeros below it. So I need to take R2 will now become R2 minus twice R1. R3 will become R3 plus R1. And R1 will not change. So 1, 2, -1, -3. So let's see, R2, 1, 2 plus -2, or 2 minus 2. So I get a 0 here. -3 minus a negative 4, so minus 4, gives me the, what is I'm looking at? It gives me 1 here. 2 minus the negative, so 2 plus 2 is 4, and then the last one I get 11. Now for the last one, I want to do 1 plus negative 1, so this gives me a 0 here, a 4, a 0, and then a negative 4. Cool. Okay, so I have my first pivot here. I've got zeros below it. From now on, I will not add the first row to anything else, to the other 2 rows. Never. Don't do it, because that will screw up your zeros. So R1 will never get added to other rows in this process. So now I have my pivot. I want to get rid of the 2 above it and the 4 below it. So R1 will get replaced with R1 minus 2 times R2. And R3 will get replaced with R3 minus 4 times R2. So this time, my second row won't change. So 2 minus 2 gives me a 0 here. 4 minus a negative, let's see, what 4 plus 2 gives me 6. And negative 3 minus 22 gives me a 25, negative 25. I did that backwards. I thought something looked funky. I added the other way. So I have negative 1 minus a negative 8. So here I get a negative 9. There we go. And the last row, I have 1. It's 4 minus 4 is 0. 0 minus 4 times 4 is negative 16. And negative 4 minus 44 gives me a negative 48. Now, I need a 0 here, sorry, a 1 here. I'm going to go ahead and divide by negative 16 just to make my life a little bit easier. Okay, so now I have my pivot here. I'm going to use the pivot to kill the 4 and the negative 9 above. So to do this, I will have R1 is equal to R1 plus 9 times R3, and R2 is equal to R2 minus 4 times R3. So I want, yes. So this will give me a 1. If I add a 0 to that, I get 1. If I add 0 to 0, I get a 0. If I add negative 9 plus 9, I get a 0. If I get negative 25 plus 3 plus 18, I get a 2. The second row, I have a 0 plus a 0, a 1 plus a 0, 4 minus 4 times 1, I get a 0 here. 11 minus 12 gives me negative 1. And the last row stays the way it is. So here I have the first non-zero number in each row is a 1. There's zeros above and below. You can't see any of this, can you? Let's try this again. You have zeros below and above all the pivots. There are no 0 rows, so that was moot. And then we have some kibble at the end. So we just took a matrix up here and put it in reduced row echelon form. Now, one quick thing to tell you what that means, because this one's easy. Suppose we had the system of equations x plus 2y minus z equals negative 3, and 2x minus 3y plus 2z equals 13, and negative x plus 2y plus z equals -1. Now, if we want to solve the system of equations, we would go through like this row minus twice that one. A lot of stuff we just did with the numbers. And that's what the matrices do. Because when I'm solving the systems of equations, when you've got 3 variables, the main thing you want to keep track of is the numbers. You don't really care if it's x, y, z, or x1, x2, whatever. So we write this in the matrix 1, 2, -1, -3, etc. And one thing I do when I am doing this in terms of an equation, I might go ahead and put a little dotted line here to remind myself that this is an equation, that this is equal to that in terms of x, y, z. And this is known as the augmented matrix. And if we looked at just this part, this is called the coefficient matrix. So I hope this video wasn't too bad, and once I finish editing, it's not too clunky. But I'll get better as we go along. What I'd like you to take away from this is I want you to be able to add 2 matrices, multiply 2 matrices, multiply through a scalar, and find the row-reduced echelon form of a matrix. I did not say anything about dividing matrices, and we're going to leave it at that because dividing is even worse than multiplying. Sort of, maybe. I don't know. Anyway, have a good week. Have fun doing all the problems I'm going to give you once I come up with them. And later, dudes.